previous lessons, you created reports by running various proc steps. You also enhanced reports by adding statements to your programs. You can use proc steps to generate reports for many different purposes. For example, you've already used procfreq and procmeans to validate data. In this lesson, you'll use SAS procedures to summarize data. Summary reports provide a concise overview of information by using descriptive statistics, such as frequency counts and percentages, sums, means, ranges, and many more. A summary report consolidates data so that each row represents multiple observations of input data. Using procfreq, procmeans, and proctabulate, you'll learn to create both summary reports and summary datasets. Here's what you learn in this lesson. Suppose you're working with Orion.sales, which contains data about Orion Star sales employees. You want to determine how many Orion Star sales employees are female and how many are male. You also want to know how many female and male employees are in each country, Australia and the United States. To generate a report that contains the information you want, you can use procfreq. Procfreq is a descriptive procedure as well as a statistical procedure. To concisely describe your data, procfreq produces frequency tables that report the distribution of variable values. Procfreq automatically displays output in a report, and you can also save the output in a SAS dataset. Procfreq also computes chi-square tests for one-way to n-way tables, and measures of association and agreement for contingency tables. Let's look at the types of frequency tables that appear in procfreq reports. As you've seen in earlier lessons, procfreq can produce one-way frequency tables for one or more variables in a SAS dataset. A one-way frequency table shows frequency statistics for all unique values of a single variable. This frequency table shows frequency statistics for the variable gender. By default, the first column displays the values of the specified variable. Each unique value is called a level of the variable. In this table, gender has two levels, F for female and M for male. For each value, a one-way frequency table shows 4 statistics by default. The frequency column displays the frequency count, which is the number of observations in a level. The percent column displays the percentage of the total number of observations. The cumulative frequency column displays the cumulative frequency count, which is the sum of the frequency counts for that level and for all levels listed above it. The cumulative percent column displays the percentage of the total number of observations in that level and in all other levels listed above it. Later in this lesson, you'll learn how to suppress the statistics that appear by default in procfreq tables. You can also specify that additional statistics be displayed. Sometimes it's helpful to cross-tabulate the frequencies of one variable's values with the values of other variables. Procfreq can create cross-tabulation tables, which summarize data for 2 or more categorical variables by showing the number of observations for each combination of variable values. Cross-tabulation tables are also called contingency tables. The simplest cross-tabulation table is a two-way table. This two-way cross-tabulation table for gender and country shows the distribution of females and males among Orion Star sales employees in Australia and the United States. By default, ProcFreak displays two-way cross-tabulation tables in table cell format. The row variable values appear on the side of the table, and the column variable values appear across the top. Each of the main cells represents a combination of a row variable level and a column variable level. For example, this cell contains frequency statistics for female employees in the United States. In addition, the last column and the last row provide totals. Outside the table is a list of the statistics that appear in each cell. 4 statistics appear by default. The frequency statistic indicates the number of observations in the table cell. The percent statistic indicates the cell's percentage of the total frequency. The row percentage is the cell's percentage of the total frequency for its row. And the column percentage is the cell's percentage of the total frequency for its column. Let's take another look at the cell for female employees in the United States. These statistics indicate that 41 observations in the dataset have a value of F for gender and a value of US for country. These 41 observations represent 24.85% of the dataset. The row percentage indicates that 60.29% of female employees are in the United States. Here's a question. What does the column percentage in this cell indicate? The column percentage indicates that 40.20% of United States employees are female. Here's another question. Which two statistics are the same in both a one-way frequency table and a cross-tabulation table? The frequency and percentage appear in both tables. Cumulative frequencies and cumulative percentages appear only in a one-way frequency table. Row percentages and column percentages appear only in a cross-tabulation table. For a frequency analysis of more than 2 variables, you can use ProcFreak to create n-way cross-tabulations. By default, an n-way cross-tabulation produces a series of 2-way tables with a separate table for each level of the other variable. For example, this 2-way cross-tabulation table is part of a 3-way cross-tabulation of gender, country, and job title. For female Orion Star employees, which is one level of the variable gender, the table shows the number of employees in Australia and the United States for each job title. In a ProcFreak report, a similar table for male employees follows this table. A ProcFreak step can include many options and statements for controlling frequency output. As you know, the table's statement specifies one or more variables that you want to analyze. Typically, you want to use ProcFreak to analyze only a subset of the variables in a dataset. However, let's start with a very basic ProcFreak step that has no tables statement. This example produces a frequency report for Orion.sales.
Let's see what happens when you create a frequency report without specifying variables. Here's our basic ProcFreak step. Let's submit the step. The results window lists all the tables that the step produced. By default, without a table statement, ProcFreak creates a separate one-way frequency table for each variable in the dataset. The first table shows frequency statistics for employee ID. This is what a one-way frequency table looks like by default. Scrolling down, we can see how long this first frequency table is. It's clear that it's a good idea to use a table statement to control the variables in a proc-freq report.
When you use proc-freq to create summary reports, it's more useful to display the distribution of values for some variables than for others. For example, look at this list of the variables in Orion.sales. Here's a question. Which of these variables are probably not useful to include in a proc-freq summary report? Employee ID, first name, and last name are not good choices for a proc-freq summary report. It's common knowledge that every employee has a unique employee ID number, and most employees have unique names. When you're summarizing data, there's no need to show a frequency distribution for variables that have a large number of distinct values. However, remember that when you validate data, looking at a frequency table for a variable like employee ID can help you to identify unwanted duplicate values. Frequency distributions work best with variables whose values meet two criteria. First, the values of the variable are categorical. Second, the values are best summarized by counts instead of averages. For example, the values of gender fall into two categories, female and male. Gender is a character variable, so its values must be counted and cannot be averaged. Here's a question. What are two other categorical variables in this list? Job title and country are also categorical variables, so they are probably good choices for a frequency distribution. What about salary, birth date, and hire date? Variables that have continuous numeric values, such as dollar amounts and dates, can result in a lengthy and meaningless frequency table. To create a useful frequency report for these variables, you can group the variable values into categories. Here's a question. How can you group the values of a variable into categories? You can group the values of a variable into categories by creating and applying formats. For example, in the last lesson, you created the tiers format, which categorizes salary values. After you group the values of a continuous numeric variable into categories, you can create a meaningful frequency table for that variable. Now, try answering this question about selecting variables for frequency tables. In a proc-freq step, the tables statement specifies the frequency tables to produce. You can define one or more frequency tables in a single tables statement. You can also specify multiple tables statements. Each tables statement creates a report that contains one or more tables. To create one-way frequency tables, you specify one or more variable names separated by a space. This example contains one tables statement that specifies the two variables gender and country. Your frequency report includes a one-way frequency table for each variable that you specify. The order in which the variables appear in the tables statement determines the order in which the one-way frequency tables appear in the report. This example creates two one-way frequency tables, a table for gender, followed by a table for country. In previous lessons, you only used proc-freq to create one-way frequency tables. However, sometimes you want to cross-tabulate the values of multiple variables and display the results in an n-way cross-tabulation table. For your report, you want to create a two-way cross-tabulation table for the variables gender and country. To create an n-way cross-tabulation table for two or more variables, you specify an asterisk instead of a space between the variable names. In a two-way table, the first variable specifies the table rows, and the second variable specifies the table columns.
Let's run the proc freq step to create a report that has one-way and two-way tables. Here's the first version of the proc freq step. In the table statement, a space separates the two variable names. Let's submit the step. The report contains two one-way frequency tables. Here's the question. What percent of Orion Star sales employees are female? Female sales employees represent about 41% of the Orion Star sales force. Here's another question. Which country has more sales employees? The United States has more sales employees than Australia. Remember that you also want to find out how many female and male sales employees are in each country. Let's modify our proc freq step. Try answering this question. What do we add to the tables statement to create a two-way cross-tabulation table? We add an asterisk between the two variable names. Let's submit the modified step. Now the report contains one two-way cross-tabulation table. The statistics in a two-way cross-tabulation table are a little more difficult to read than the statistics in a one-way table. Let's take a closer look at the statistics for female sales employees in Australia. Orion.sales contains observations for 27 female employees in Australia. These 27 employees are 16% of the total Orion Star sales force, 40% of all female sales employees, and 43% of all Australian sales employees. Here's a question. Which country has a higher percentage of female sales employees? In Australia, over 42% of sales employees are female. In the United States, only about 40% are female.
To enhance your proc freq reports, you can use additional statements. In your proc freq step, you can add statements like a where statement, a format statement, and a label statement. You can also add global statements like the option statement, the ODS statement, the title statement, and the footnote statement. Look at this enhanced version of the program we've been working with. Here's a question. Can you identify the additional statements as well as an additional procedure? A proc format step creates the format $country format, which specifies that country names should appear instead of the country codes stored in the dataset. An ODS statement creates an RTF file and applies a style definition. At the end of the program, another ODS statement closes the RTF destination. To learn the default ODS destination in SAS 9.3, as well as the enhancements that have been made to ODS, click SAS 9.3. Several new statements appear in the PROC-FREAK step. The where statement subsets the data so that the analysis includes only employees who have rep in their job title. The format statement applies the format $country format to the variable country. And the title statement specifies a title for this report.
Let's run our program to create an enhanced PROC-FREAK report. Here's the report that we created in the last demonstration by running a basic PROC-FREAK step. Now let's submit this modified PROC-FREAK step to see what the enhanced report looks like. Here's the RTF file that the ODS statement created. Notice that the style definition we specified changed the colors and fonts. As the title indicates, the report is now based only on sales employees who have rep in their job title. Full country names are now displayed instead of country codes. This enhanced report looks quite different from the basic report.
Another way to modify your PROC-FREAK output is to add one or more options to your PROC-FREAK step. For example, you can add options in the PROC-FREAK statement and in the tables statement. N levels is an option that you can specify in the PROC-FREAK statement. As you learned in an earlier lesson, the N levels option displays a table at the top of your PROC-FREAK report that shows the number of levels or distinct values for each variable listed in the table statement. No print is an option that you can add to the tables statement. In a PROC-FREAK report, the no print option suppresses the frequency tables and shows only the table of levels that the N levels option creates. In the tables statement, notice that you must specify a / before you specify one or more options. In the PROC-FREAK statement, you do not specify a /. Next, let's take a look at some of the other options that you can use to modify PROC-FREAK output. This one-way frequency table shows the 4 statistics that PROC-FREAK displays by default. Suppose you want the frequency tables in this report to display only a subset of the available statistics. By specifying options in the tables statement, you can suppress one or more of the statistics in frequency tables. To suppress statistics in one-way frequency tables, you can specify the no cum and no % options in the tables statement. Let's see how each of these options affects a one-way frequency table like this one. The no cum option suppresses the display of cumulative frequencies and percentages. The no % option suppresses the display of all percentages. You can also specify both no cum and no %. When you specify multiple options, you separate them by a space. Here's a question. If we specify both no cum and no %, which statistics appear in the frequency table? If we specify both no cum and no %, the one-way frequency table displays only frequencies. To suppress the display of statistics in a cross-tabulation table, you also specify options in the tables statement. Remember that only some of the statistics shown in cross-tabulation tables and one-way frequency tables are the same. Here's a question. Do you think you can use the no cum option for a cross-tabulation table? You cannot use the no cum option for a cross-tabulation table because cross-tabulation tables do not display cumulative statistics. You can use the no percent option for cross-tabulation tables as well as one-way frequency tables. In a cross-tabulation table, no percent suppresses the display of overall percentages. These percentages include the second row for each level and the second row in the total level. The no percent option does not affect row percentages or column percentages. Now, let's look at the additional options that you can specify in the tables statement to suppress statistics in a cross-tabulation table. The no freq option suppresses the display of cell frequencies. No row suppresses the display of row percentages. And no col suppresses the display of column percentages. Now, try answering a question about suppressing statistics in frequency reports. Suppose you find the cross-tabulation tables that ProcFreq produces by default to be difficult to read. To simplify the format of these tables, you can specify additional options in the tables statement. To display cross-tabulation tables in list format, you specify the list option. In the list version of this two-way cross-tabulation table, notice that the first two columns specify each possible combination of the two variables. All statistics for each combination are displayed in a single row. Here's a question. What's the difference between the statistics in the default version and those in the list version? The statistics in the list version are the same as in a one-way table. The cumulative frequency and cumulative percentage appear instead of the row percentage and the column percentage. To format your cross-tabulation table in the cross-list format, you specify the cross-list option in the tables statement. Like the list format, the cross-list format might be easier to read than the default format. However, notice that the cross-list format displays the same statistics as the default cross-tabulation table. Suppose you want to change the format of all frequency values in a cross-tabulation table. For example, in this ProcFreq step, the format statement applies the user-defined format $country format to the values of country. In the listing output, the columns are not wide enough to accommodate the formatted variable values, which are full country names. SAS applied a default format to all the frequency values, which controls the column width. To change the format that SAS applies to all the frequency values in the table, you can add the Format Equals option to the tables statement. In the Format Equals option, you can specify any standard SAS numeric format or a user-defined numeric format. The format length cannot exceed 24. In this example, suppose we want to specify a length of 12 for the frequencies. Here's a question. Which numeric SAS format specifies a length of 12? The SAS format 12 dot specifies a width of 12 for the frequency values. When we run this program, our listing output goes from this to this. All frequency values are now formatted with a length of 12. In wider columns, the formatted variable values Australia and United States now fit on a single line. You cannot use the Format Equals option if you specify the list or cross-list option. As you've learned, SAS divides listing output into pages by default. For example, this ProcFreak step creates 4 pages of listing output. The first 2 one-way frequency tables are for gender and country. These 2 tables are short, and they both appear on the first page of the report. By default, SAS begins a new one-way table on the current page only if the entire table fits on that page. The third one-way frequency table requires 3 pages because hire date has many distinct values. You can control how SAS places one-way tables on pages of listing output by adding either the page option or the compress option at the end of the ProcFreak statement. The page option specifies that each one-way frequency table begin on a new page, regardless of the table's size. In the listing output for this example, the frequency table for country now begins on page 2. The hire date table starts on page 3 and now extends to page 5. When you use the page option, the number of pages in listing output often increases. However, if you want to reduce the number of pages in your frequency report, you can specify the compress option. If a page has any room left at the bottom, the compress option begins the next table on the same page. In the listing output for this example, the frequency table for country moves back to page 1, as does the beginning of the hire date table. The compress option only affects one-way frequency tables. Cross-tabulation tables that cannot fit on a single page always begin on a new page.
Let's run our ProcFreak step and control the pages in 3 different ways. To start, we want to see how SAS places the frequency tables on pages by default. Let's submit the ProcFreak step without any options. In the listing output, notice that the first 2 tables appear on the first page of the report. There's a lot of empty space at the bottom of this page. However, SAS starts the third table for hire date on page 2. Here's a question. If the third one-way table was small enough to fit entirely on page 1, would SAS place it on page 1? Yes, SAS does place a new one-way table on the current page if the entire table fits on that page. The hire date table extends to the 4th page of the report. Now let's add the page option to the ProcFreak step. We submit the step. In the listing output, notice that the first page now contains only the table for gender. Each table in the report starts on a new page. The entire report has expanded to 5 pages. Finally, let's use the compress option instead of the page option. We submit the step. In the listing output, notice that the first page now contains the first 2 tables as well as the beginning of the table for hire date. The report now ends on page 3, so we've made it shorter.
Now, try practicing in your SAS software. This summary report contains two frequency tables. One shows the distribution of Orion Star employees by gender, and the other shows the distribution by country. Now, suppose you want to create an output data set that contains summary statistics for these variables. You can create output data sets in two ways by using ProcFreq. To create a data set that contains frequencies and percentages, you can add the out equals option to the tables statement. To create a data set that contains specified statistics, such as the chi-square statistic, you can add an output statement that contains the out equals option to your ProcFreq step. First, let's create an output data set by adding the out equals option to the tables statement. You add the out equals option after the /. The out equals option names an output data set that contains frequency counts and percentages for a frequency table or a cross-tabulation table. If the tables statement specifies variables for more than one table, the contents of the out equals data set correspond to the last table specified. In this example, the out equals option specifies a temporary output data set named Freq1. The table statement specifies a one-way frequency table for gender and another for country. Here's a question. For which table would the output data set contain frequency counts and percentages? The contents of the output data set Freq1 will correspond to the one-way frequency table for country, the last table listed in the tables statement. A one-way frequency table contributes just one variable to the output data set. In this example, the variable is country. In this second example, the only table specified is a two-way cross-tabulation table. A two-way table contributes two variables to the output data set. Here, gender and country. The output data set also includes two variables that ProcFreq creates automatically, count and percent. Count contains the frequency counts, and percent contains the percentages. The output can also contain other frequency and percentage variables that you can request by specifying additional options in the tables statement. You'll learn more about these options later in this lesson. Finally, if your ProcFreq step contains a by statement to group observations, the by variables also appear in the output data set. When you specify the out equals option in the tables statement, your ProcFreq step still creates a ProcFreq report as well as an output data set by default. To suppress the display of the ProcFreq report, you can add the no print option in the ProcFreq statement. In this example, the no print option now appears in the ProcFreq statement. This ProcFreq step will no longer display a ProcFreq report.
Now let's run the ProcFreq step to create an output data set with the default variables. Let's run several different versions of this ProcFreq step. We'll compare the contents of the ProcFreq report with the contents of the output data set for both one-way frequency tables and cross-tabulation tables. Then we'll use the no print option to suppress the ProcFreq report. We'll start with a ProcFreq step that creates one-way frequency tables for gender and country. Below the ProcFreq step, we've added a ProcPrint step to print the output data set. Now let's submit the program. In the results window, notice that SAS created both a ProcFreq report and a ProcPrint report. First, let's look at the ProcFreq report. This report contains tables for both gender and country and displays 4 statistics by default: frequency, percent, cumulative frequency, and cumulative percent. Now let's look at the proc print report to see the contents of the output dataset. As expected, the output dataset contains summary statistics for the variable country, not for gender. The output dataset for a one-way frequency table contains one observation for each distinct value of the variable. This output dataset has two observations, one for each distinct value of the variable country. In addition to the country variable, the output dataset also contains the automatic variables count and percent. The obs column, of course, is not a variable in the dataset. Here's a question. Which statistics appear in the proc freq report but not in the output dataset? The output dataset does not contain the cumulative frequency and cumulative percent. Now let's modify the proc freq step so that it creates a two-way cross-tabulation table for gender and country. We just add an asterisk between the two variable names. We'll also change the name of the output dataset to freq2. Now let's submit the program. In the proc freq report, the cross-tabulation table displays frequency counts, percentages, row percentages, column percentages, and totals. The proc print report shows that this output dataset, freq2, has more observations and variables than the output dataset we generated before freq1. For a cross-tabulation table, the output dataset contains one observation for each combination of variable values. This dataset contains both of the variables gender and country, as well as the automatic variables count and percent. So, for a cross-tabulation table, many of the statistics shown in the proc freq report do not appear in an output dataset by default. Let's make one more change to the proc freq step. We'll add the no print option to the proc freq statement. Let's submit the program. In the results window, notice that the program created only a proc print report. The no print option suppressed the proc freq report.
By default, the output datasets for both one-way frequency tables and cross-tabulation tables contain only the two statistics, count and percent. To include additional statistics in your output datasets, you can specify additional options in the tables statement. For one-way frequency tables, the outcum option specifies that the cumulative frequency and cumulative percentage be included in the output dataset. For cross-tabulation tables, the out% option specifies that the percentage of column frequency and row frequency be included in the output dataset.
Now let's use proc freq to create output datasets that have additional statistics. We'll start with this program, which has two proc freq steps. One proc freq step creates an output dataset based on a one-way frequency table. The other proc freq step creates an output dataset based on a two-way cross-tabulation table. In a previous demonstration, you saw the statistics that proc freq includes in these tables by default. To include additional statistics in each output dataset, let's add an option to the table statement in each proc freq step. Here's a question. In the first proc freq step, which option can we specify to add statistics to the output dataset? For a one-way frequency table, the outcum option adds the cumulative frequency and the cumulative percentage to the output dataset. Here's another question. In the second proc freq step, which option can we specify to add statistics to the output dataset? For a cross-tabulation table, the out percent option adds the percentage of column frequency and the percentage of row frequency to the output dataset. Let's submit the code. In the proc print output for the first dataset, Freq3, the cumulative frequency and cumulative percent columns now appear. Now let's look at the second dataset, Freq4. This dataset now contains the additional columns percent row and percent column.
Another way to create output datasets is to add the output statement with the out equals option to your proc-freq step. The out equals option specifies the name of an output dataset. You can also add one or more options to the output statement to specify the statistics you want to include in the output dataset. In this example, the output statement creates the output dataset Freq5. The option for the chi-square statistic appears at the end of the output statement. Notice that the output statement, unlike the tables statement, requires no / before the options. Many options are available for specifying statistics in the output statement. You must specify a tables statement with the output statement. In the tables statement, you must specify the same options for statistics that you specify in the output statement. The options in the tables statement tell proc-freq to compute the statistics, and the options in the output statement tell proc-freq to output the statistics. If your tables statement specifies multiple tables, the contents of the output dataset correspond to the last table. If you use multiple tables statements, the contents of the output dataset correspond to the last table statement. In this example, the output dataset will contain statistics for the variable country, which appears last in the tables statement. The output dataset created by the output statement is not the same as the output dataset created by the out equals option in the tables statement. The output statement creates a dataset that contains statistics other than frequency counts and percentages. So the output dataset does not include variables for frequencies, percentages, or the variables on which the table is based. Instead, the output dataset includes the statistics that you specify as options and any associated standard error, confidence limits, p-values, and degrees of freedom. The output dataset also includes the variable n, which indicates the number of observations. Finally, if your proc-freq step contains a by statement to group observations, the by variables also appear in the output dataset.
Now let's create an output dataset that contains chi-square statistics. In this program, the tables statement specifies two one-way frequency tables for gender and country. In the output statement, the out equals option creates the output dataset Freq5. The chi-square option indicates that we want the output dataset to include chi-square statistics. Let's submit the program. In the results window, notice that this program created only a proc-freq report, not a proc-print report. Let's check the log to see what happened. In the proc-print step, an error message indicates that Freq5 does not exist. Let's look for messages near the proc-freq step to figure out why the output dataset was not created. Here's a question. Why didn't the proc-freq step create an output dataset? A warning message says that no statistics are requested in the tables statement. we forgot to specify the chi-square option in the tables statement, so SAS could not calculate the chi-square statistics. There were no statistics to include in an output dataset, so ProcFreak could not create the dataset. Let's take a quick look at the ProcFreak report. We did not request any statistics in the tables statement, so the ProcFreak report contains only 2 one-way frequency tables. Now let's correct our program so that we can generate the output dataset. We add a / and the chi-square option to the table statement. Then we submit the modified program. This time, the results window shows that the program generated both ProcFreak and ProcPrint output. First, let's look at the ProcFreak report. Now, this report contains a table of chi-square statistics for each variable, in addition to the one-way frequency table. Next, let's look at the ProcPrint report to see the contents of the output dataset. The n variable indicates that there are 165 observations. The _p chi_ variable contains the chi-square statistic. The other 2 columns contain the degrees of freedom and the p-value, respectively.
You've learned to create one output dataset by using the out equals option in either the tables statement or the output statement. You can also create multiple output datasets by adding the out equals option to both statements in the same ProcFreak step. In this example, the tables statement creates the output dataset Freak6. The outCum option adds the cumulative frequency and cumulative percent to the output dataset. The output statement creates the output dataset Freak7. The chi-square option in the output statement specifies that chi-square statistics appear in Freak7. The chi-square option in the tables statement calculates chi-square statistics for the ProcFreak report and for Freak7. After you create multiple datasets, you might want to combine statistics and variables from these datasets into a single dataset. To see an example of combining multiple ProcFreak output datasets into one dataset, click Details.
Now let's run the ProcFreak step to create multiple output datasets. The program is in the editor. In the ProcFreak step, notice that the tables statement specifies only one variable, country. After the ProcFreak step, we've added 2 ProcPrint steps to print the 2 output datasets. Let's submit the code. This program generated a ProcFreak report and 2 ProcPrint reports. The ProcFreak report contains the default statistics from the one-way frequency table, the cumulative statistics that the outCum option specifies, and a separate table containing chi-square statistics. The first ProcPrint report shows that the output dataset Freak6 contains the same statistics as the first table in the ProcFreak report. Notice that even though the chi-square option appears in the table statement, this output dataset does not contain chi-square statistics. The second ProcPrint report shows that the output dataset Freak7 contains chi-square statistics.
Now, try practicing in your SAS software. Suppose you want to analyze the salaries of Orion Star sales employees. You want to see summary statistics for all sales employees, and then for female and male employees in Australia and the United States. To create the output you want, you can use proc means. Proc means provides data summarization tools to compute descriptive statistics for continuous numeric variables across all observations and within groups of observations. Proc means automatically displays output in a report, and you can also save the output in a SAS dataset. By default, proc means reports the number of non-missing values of the analysis variable, n, and the mean, the standard deviation, the minimum value, and the maximum value of every numeric variable in a dataset. By using additional statements and options in a proc means step, you can create a more complex proc means report. For example, your report can display statistics for groups of data. In earlier lessons, you learned the syntax of a basic proc means step. This example creates a report that displays the default proc means statistics for the analysis variable, salary. In this lesson, you'll learn to create more complex proc means output by using additional statements and options in a proc means step. This basic proc means report shows statistics about Orion Star sales salaries that are calculated across all observations. However, sometimes you want to see statistics for groups of observations. For example, you'd like to see these statistics grouped by gender and by country. To calculate statistics for groups of observations in proc means, you use the class statement. You already know that the var statement specifies one or more numeric variables that proc means analyzes. The class statement specifies variables that proc means uses to group the data. These variables are called classification variables, or class variables. Each combination of class variable values is called a class level. In this example, proc means reports the statistics for salary for each combination of values, or each level of the class variables, gender and country. In your proc means output, the class variables appear in the order that you list them in the class statement.
Let's run this program to create a proc means report that has grouped data. Here's the proc means step in the editor. Let's submit the code. Notice that this report has 3 more columns and more rows than the basic proc means report we saw earlier. The table now has a column for each of the class variables, gender and country. Proc means reports statistics for each class level, so there's a row for each combination of class variable values. Here's the question. What is the mean salary for male employees in Australia? The mean salary for male employees in Australia is $32,001.39. When you use the class statement, proc means displays the additional statistic n-obs in your report. Remember that the n statistic counts all non-missing values of the analysis variable. However, n-obs reports the total number of observations that proc means processes for each class level, whether or not there are missing values. If a dataset has missing values, the values of n and n-obs for some levels are different. Here's a question. Based on the values of n and n-obs, does this dataset have missing values of salary? For each level, the values of n and n-obs are identical. This dataset does not have missing values.
The statistics that proc means displays by default are not always the ones that you need. You might prefer to display additional statistics, display only a subset of statistics, or display the statistics in a different order. To control the statistics that proc means displays, you include statistic keywords in the proc means statement. Your proc means output includes the statistics that you specify in the order that you specify them. In this example, the proc means statement includes the three statistic keywords, sum, mean, and range. As this output shows, when you specify one or more statistics in the proc means statement, proc means does not produce the default statistics. Sum, mean, and range are just three of the many statistic keywords that are available for use in proc means. To see a table of all proc means statistics, click Details. In your proc means reports, you might want to control the number of decimal places in the numeric values that are displayed. When SAS code does not specify a format for writing numeric values, SAS uses the best W dot format as the default format. The best W dot format writes values with the maximum precision as determined by the field width. Integers like the values of n-obs are written without decimals. To control the number of decimal places in the numeric values that appear in output, you can specify the max DEC equals option in the proc means statement. In the max DEC equals option, n is an integer that specifies the maximum number of decimal places. In this example, the max DEC equals option specifies that SAS write numeric values with no decimal places.
Now let's see what happens when we run a proc means step that specifies and formats statistics in the report. Here's the proc means step that we ran in the last demonstration to group data. Let's add the statistics keywords sum, mean, and range. Now let's submit the code. The proc means report now has an n-obs column and the three statistics that we specified. The default statistics do not appear. Notice that the sum, mean, and range values are displayed with 2 decimal places. Now suppose we decide to change the statistics specified in the proc means statement. Here's a question. How do we display just the sum and the mean and reverse their order? We specify mean and sum in the proc means statement. Let's also add an option that specifies the number of decimal places. Here's another question. What option sets the decimal places to 0? We specify max DEC equals 0 in the proc means statement. Now let's submit the code. The proc means report displays the two statistics we specified. The values of mean and sum have no decimal places.
If you are working with listing output, suppose you want to control the field width of the statistical variables. In this example, proc means displays the two specified statistics by using the default field width of 12. Notice that the statistical values appear with 2 decimal places. To control the field width, you can use the FW equals option in the proc means statement. In the FW equals option, n is an integer that specifies the field width. In this example, the FW equals option specifies a field width of 15. In the listing output from this proc means step, the field width of the statistical variables has increased. Proc means now displays more decimal places for these values. The FW equals option does not affect HTML output. Let's take another look at this proc means step that we ran earlier. The proc means statement does not specify any statistic keywords, so the report displays the default statistics. The class statement causes the NOBS statistic to appear as well. In this example, the values of NOBS and N are identical for each class level, which indicates that salary has no missing values. Suppose you don't want the NOBS column to appear in your report. To suppress the NOBS column, you can specify the No NOBS option in the proc means statement. In this example, No NOBS now appears at the end of the proc means statement. The output from the modified proc means step is shown here. When you specify the No NOBS option, the NOBS column no longer appears in proc means output. Now, try answering a question about specifying statistics and options in the proc means statement. To enhance your proc means reports, you can use additional statements in and around your proc means step. To start, let's look at this fairly basic proc means step. By adding statements, we can enhance the report in a variety of ways, such as creating an output file, subsetting observations, applying formats to variables, and adding a title. In this modified example, the program has been enhanced. Let's look at what's been added. A proc format step creates the format $country format, which specifies that country names should appear instead of the country codes stored in the dataset. An ODS statement creates an external HTML file and applies a style definition. At the end of the program, another ODS statement closes the HTML destination. To learn the default ODS destination in SAS 9.3, as well as the enhancements that have been made to ODS, click SAS 9.3. The HTML output is shown here. Like proc means, proc summary provides data summarization tools to compute descriptive statistics for variables across all observations and within groups of observations. As shown here, proc summary uses the same syntax as proc means. There are two differences between proc means and proc summary to keep in mind when you're choosing between these procedures. The first difference is that proc means displays a report by default, but proc summary does not. With proc means, the print option is set by default, and you must specify the no print option if you want to suppress the report. With proc summary, the no print option is set by default, and you must specify the print option to display a report. The second difference between proc means and proc summary relates to the var statement. Omitting the var statement in proc means and proc summary produces different results. When there is no var statement, proc means produces an analysis of all numeric variables. However, without a var statement, proc summary produces a simple count of observations. Now, try practicing in your SAS software. This proc means step creates a report to show statistics for salaries of Orion Star sales employees. Now, suppose you want to use proc means to create an output dataset that contains these summary statistics. To create an output dataset by using proc means, you can add an output statement that contains the out equals option. Earlier, you learned to use the out equals option in the output statement in a proc freak step. The syntax of the output statement with the out equals option is shown here. After naming the output dataset, you can specify statistics to include in the output dataset. First, let's look at a basic example in which the output statement does not specify statistics. Here, the output statement creates the output dataset means1. Notice that the proc means statement specifies the statistics sum, mean, and range. Statistics that are specified in the proc means statement appear only in the proc means report, but have no effect on the output dataset. In fact, since we're concerned only with the output dataset, we can remove the statistics listed in the proc means statement as shown. Here's a question. What option can we add to suppress the report and generate only a dataset? The no print option suppresses the display of the proc means report. Whether or not you specify statistics in the output statement, proc means creates an output dataset that contains several types of variables. 5 variables, if any, class variables, and automatic variables named _type_ and _freak_. The remaining variables in an output dataset are determined by whether you specify output statistics in the output statement. It's more common to specify statistics in the output statement than to use the default statistics. However, let's start by looking at the output dataset that this step creates, which includes the default statistics. This partial proc print output shows the dataset that this proc means step creates. The proc means step has no by statement, so the output dataset contains no by variables. Gender and country are the class variables. _type_ and _freak_ are automatic variables. _type_ is a numeric variable that shows which combination of class variables produce the summary statistics in each observation. We'll take a closer look at _type_ a bit later. The last two variables, _stat_ and salary, show the statistics that SAS displays by default when you don't specify statistics in the output statement. The statistics that appear by default are N, the number of non-missing values, the minimum value, the maximum value, the mean, and the standard deviation. Now, let's look at how to specify output statistics in the output statement. An output statistic specification has 3 parts, which are shown in these examples. An output statistic specification begins with a statistic keyword that tells proc means which statistic to calculate. You can choose from the same set of statistic keywords here as you used earlier in the proc means statement for reports. Next, you specify an equal sign. And last, you specify the name of the variable that will contain the values for that statistic in the output dataset. For example, the last output statistic specification tells proc means to calculate the mean, and then to store the mean values in a variable named average salary in the output dataset. In this program, the output statement now creates the output dataset means2. The output statement also contains 4 output statistic specifications, which you just saw as examples.
Now let's run our proc mean step to create an output dataset with statistics that we specify. In this program, we've added a proc print step to show the output dataset that the proc means step produces. Let's submit the code. As the proc print output shows, the first 4 variables in this dataset are the same 4 variables that appeared before you specified statistics in the output statement. The 2 class variables and the automatic variables _type_ and _freak_. However, the _stat_ and analysis variable columns no longer appear. Instead, here are the 4 variables that you specified in the output statement.
Let's take a closer look at the automatic underscore type underscore variable. In an output dataset, procmeans creates underscore type underscore as a numeric variable by default. This partial procprint output shows all of the values of underscore type underscore in this output dataset, which range from 0 to 3. The dataset has two additional observations with an underscore type underscore value of 3 that are not shown here. Also, the procprint step that created the report is not shown here. Each value of underscore type underscore indicates which combination of class variables produced the summary statistics in that observation. In other words, each underscore type underscore value indicates a different level of summarization. Notice that only the first observation has the underscore type underscore value 0. In this observation, no values appear for gender and country. The underscore freak underscore value for this observation is 165, which is the total number of observations in the dataset. Here's a question. What level of summarization do you think the underscore type underscore value 0 indicates? The underscore type underscore value 0 indicates that procmeans summarized all of the data in the dataset and stored the results in one observation. So the first observation contains the overall summary statistics. Observations 2 and 3 have an underscore type underscore value of 1, and they display different values of country. No values are listed for gender. The underscore type underscore value 1 indicates that procmeans calculated the statistics for each level of the class variable listed second in the class statement. In this example, country is listed second. So these observations summarize data by country. If you add up the underscore freak underscore values for both observations that have the underscore type underscore value 1, the total will equal the number of rows in the dataset. Observations 4 and 5 have an underscore type underscore value of 2, and they display different values of gender. No values are listed for country. Here's a question. What do you think the underscore type underscore value 2 indicates? The underscore type underscore value 2 indicates that procmeans calculated the statistics for each level of the class variable listed first in the class statement. In this example, gender is listed first. So these observations summarize data by gender. Finally, notice that the rows that have an underscore type underscore value of 3 contain values for both gender and country. So these observations summarize data by both of the class variables. In this example, the procmeans step specifies two class variables. As the number of class variables increases, the number of unique values of underscore type underscore also increases. However, the value 0 always represents data that has been summarized across the entire input dataset. The underscore type underscore variable can be useful when you want to use only some of the data in the output dataset. For example, suppose we want the procprint report of the output dataset to display only the data that is summarized based on the values of gender, the first class variable listed. The procprint step, which is shown here, now contains a where statement. We need to add a where expression that selects only the observations with a particular value of underscore type underscore. Here's a question. Which underscore type underscore value indicates that the data is summarized by the values of gender? We want to select all observations that have an underscore type underscore value of 2. The procprint report is shown here. In the procmeans statement, you've already specified the no print option to suppress the printing of the output report. You can also control the contents of output data sets in various ways by specifying other options in the proc_means statement. For example, suppose you want your output data set to include only the observations that report summary statistics based on the values of all specified class variables. The _type_value 3 indicates that proc_means calculated summary statistics based on the values of both class variables. Remember that only the partial proc_print output is shown here. In the output data set means2, two more observations have an _type_value of 3 that are not shown here. To restrict your output data set to only the observations that have the highest _type_value, you can specify the n-way option in the proc_means statement. The n-way option subsets the data that proc_means writes to the output data set. After we add n-way to the proc_means statement, the output data set contains only 4 rows. These 4 rows all have the _type_value 3, which is the highest value of _type_ produced by this proc_means step. This set of observations shows every possible combination of unique values of the two class variables. By default, the observations in the output data set are sorted in ascending order by the values of _type_. Now, suppose you want to sort the observations in the output data set by _type_ values in descending order. To sort the output data set by _type_ values in descending order, you can specify the descend types option in the proc_means statement. Now that descend types is specified, the observations in the output data set are sorted by descending values of _type_. Let's remove descend types and return to an output data set that is sorted by ascending values of _type_. As you know, proc_means creates _type_ as a numeric variable by default. Now suppose you want the _type_ variable in the output data set to be a character variable. You want _type_ to store character representations of the binary values, which indicate the combinations of class variables that created the statistics. These character values consist of combinations of zeros and ones. For example, the numeric _type_ value 2 corresponds to the character value 10. To specify that the values of _type_ be character values, you can use the character type option. In the output data set, _type_ now stores character values. The character representation of an _type_ value is useful because it indicates which class variable or variables contributed to the statistics in an observation. Each position in the character value represents one variable in the class statement. In this example, the _type_ values have 2 positions because the proc_means step specifies 2 class variables. Let's look at the _type_ value 10. The first position represents the class variable gender, and the second position represents country. A 1 indicates that proc_means calculated statistics based on the values of the corresponding class variable. A 0 indicates that proc_means did not use the class variable to calculate statistics. So the value 10 indicates that gender contributed, but country did not. Here's a question. If the _type_ value is 11, which class variables contributed to the statistics? Both class variables contributed to an observation that has the _type_ value 11. The character values that correspond to the numeric _type_ values 0 through 3 are shown here. Take a moment to answer a question. After you create output datasets by using proc means, you can use them in many different ways. For example, you can create a proc means output dataset, merge it with a detail dataset, and then create a report from the merged dataset. To see the code and the report for this example, click Details. Now, try practicing in your SAS software. Suppose you want to create a report that displays the distribution of Orion Star sales employees by country, gender, and job title. You also want to display summary statistics about sales salaries. To create a report that contains the tables you want, you can use Proctabulate. Proctabulate displays descriptive statistics in tabular format by using some or all of the variables in a dataset. When you design Proctabulate reports, you can choose from a large number of descriptive statistics. Many of these statistics are the same as statistics that other procedures compute, such as ProcFreq and ProcMeans. Proctabulate automatically displays output in a report, and you can also save the output in a SAS dataset. To plan a Proctabulate report, you follow 4 main steps. Select variables for classifying or grouping your data, if any. Select variables for analyzing your data, if any. Identify the statistics that you want to display. Design the table that you want to represent your data. For a Proctabulate report, you must specify at least one class variable or one analysis variable. If you want, you can specify both. You've already worked with class variables and analysis variables in ProcMeans. Let's review the differences between class variables and analysis variables. Class variables can be character or numeric, and usually have only a few distinct values. It makes sense to compute frequency counts on a class variable. For example, you might select country as a class variable and calculate the number of sales employees in each country. Analysis variables must be numeric and often contain continuous values. You can summarize analysis variables by calculating statistics, such as a sum or an average. For example, you might select salary as an analysis variable and display average salaries by a class variable, such as country. You'll select statistics based on the variables you've chosen. You might want to use the statistics that Proctabulate displays by default, or you might want to request other statistics. Finally, you design the table that best represents your data. In other words, you decide how you want to display the variables and statistics in a table format. Proctabulate reports contain 1, 2, or 3-dimensional tables that contain variables and statistics. A 1-dimensional table displays one or more variables in the column dimension. This 1-dimensional table displays the statistic n for the variable country. A 2-dimensional table displays one or more variables in each of the 2 dimensions, the column dimension and the row dimension. This 2-dimensional table displays the statistic n for the 2 variables country in the column dimension and gender in the row dimension. A 3-dimensional tabular report contains a series of tables that display variables in the column dimension, the row dimension, and a 3rd dimension that is called the page dimension. What you actually see in a 3-dimensional report is a series of 2-dimensional tables that have headings that represent the page dimension. The tables shown here, which are part of a larger report, display the statistic n for the 3 variables country in the column dimension, gender in the row dimension, and job title in the page dimension. In HTML output, which is shown here, 3-dimensional tables appear on one long page. However, in listing output, each table in a 3-dimensional report appears on a separate page. When you're planning a report, consider how many dimensions you want to use and which variables you want to display in each dimension. Let's look at the syntax of a Proctabulate step. 4 statements that are commonly used in Proctabulate are: the proc tabulate statement, the class statement, the var statement, and the table statement. The proc tabulate statement specifies the input dataset and can also contain options. In this example, the proc tabulate statement specifies Orion.sales as the input dataset. No options appear in this proc tabulate statement. The class statement specifies class variables, and the var statement specifies analysis variables. In this example, job title, gender, and country are specified as class variables. Salary is specified as the analysis variable. In both the class and var statements, you list one or more variables separated by a space. You can include just a class statement or just a var statement, or both. However, you cannot specify the same variable in both the class and the var statement. The table statement defines a table that appears in the report. Don't confuse this statement with the tables statement in ProcFreq, which has a different syntax. In ProcTabulate, the table statement contains from 1 to 3 dimension expressions that define the table: a page expression, a row expression, and a column expression. At the end of the table statement, after the dimension expressions, you can also specify options following a /. To specify multiple tables for your output, you can include multiple table statements in your ProcTabulate step. This example includes just one table statement. Let's look more closely at how you define output tables by specifying 1, 2, or 3 dimension expressions in the table statement. Each expression specifies the variables, or the variables and statistics, that appear in that dimension of the table. As you saw earlier, the number of dimension expressions that you specify determines the dimensionality of the tables that ProcTabulate produces. The column expression is required, which means that tables always contain columns. Specifying only a column expression creates a one-dimensional table. For a two-dimensional table, you specify a row expression and then a column expression. And for a three-dimensional table, you specify a page expression, a row expression, and then a column expression. In a dimension expression, the column expression is always the rightmost expression. When you specify multiple dimension expressions in a table statement, it's important to specify them in the order shown so that ProcTabulate knows which is which. You separate multiple dimension expressions by commas. In a table statement, the number of dimensions is one more than the number of commas. Let's take a closer look at how you specify variables in dimension expressions. All variables that you specify in dimension expressions in the table statement must appear in either the class statement or the var statement. In this table statement, the page expression specifies an analysis variable. The row expression and the column expression each specify a class variable. Here is the three-dimensional table that this table statement creates. The dimension expression in this table statement specifies only variables and no statistics. When no statistics are specified, the table displays the default statistic, in this example, the sum statistic. You'll learn how to specify statistics later in this lesson. This next table statement shows one way to combine multiple variables in a single dimension expression. Placing an asterisk between variable names creates categories from the combination of variable values, a process called crossing. In the resulting table, notice that both gender and country appear in the column dimension. The table displays the default statistic n for each combination of these class variables. An asterisk is one example of an operator. In a dimension expression, operators indicate the relationship between multiple elements. If you specify a blank instead of an asterisk between variable names, the output for the two variables is concatenated. Now that this table statement has a blank instead of an asterisk, the resulting table displays the values of n for the two variables, one after another. However, The table does not display statistics for combinations of values of the two class variables. Now, let's look at a different example. This proc-tabulate step contains 3 table statements. These statements define a one-dimensional table, a two-dimensional table, and a three-dimensional table. Here's a question. In all tables in this report, which variable will appear in the column dimension? Country will always appear in the columns because it is in the last dimension expression in all 3 table statements. Here's another question. Do these table statements list class variables, analysis variables, or both? Country, gender, and job title are all listed in the class statement. No analysis variables are specified in these dimension expressions. Now let's add another table statement, which has one dimension expression. Here, the dimension expression specifies both a class variable and an analysis variable. The asterisk operator crosses the class variable country with the analysis variable salary.
Now let's run a proc-tabulate step to create simple 1, 2, and 3-dimensional tables. The proc-tabulate step is in the editor. Let's submit the code. We'll look at the HTML output first. Notice that the default SAS title appears at the top of each table. As expected, the country variable appears in the columns in the first 3 tables. In the last table, which crosses country and salary in the column dimension, both variables appear in the columns. Now let's look at the listing output for the first table, a one-dimensional table. In the listing output, the output from each table statement appears on a separate page. Here's the two-dimensional table. The three-dimensional table is a series of tables, and each one appears on its own page.
Now, answer a question. Now, let's take a closer look at the statistics in dimensional tables. The first 3 tables that we just created in the demonstration all contain the statistic n, which is the number of non-missing values. When a table statement contains only class variables, proc-tabulate displays n by default. The 4th table we just created crosses the class variable country with the analysis variable salary. Notice that the sum statistic is displayed in this table. If a table statement contains any analysis variables, proc-tabulate displays the sum statistic by default. Often, you want your tables to display statistics instead of or in addition to the default statistics. You specify statistics in a dimension expression in the table statement. To specify statistics, you use the asterisk operator to attach one or more statistic keywords to a variable or combination of variables. The statistics and variables appear in tables in the same order that you specify them in a dimension expression. For example, in this table statement, the keyword for the percent of total frequency is now attached to the class variable country. Here's the table that this table statement creates. Notice that the country headings appear before the PCTN headings because country is specified first in the dimension expression. In this example, the table statement specifies the 2 statistics min and max, which are enclosed in parentheses. The asterisk operator attaches these statistics to the crossed variables country and salary. Here's a question. How can you tell that this table statement has only one dimension expression? This table statement has no commas. You use commas to separate multiple dimension expressions. Here's the table that this table statement creates. The variable and the two statistics all appear in the column dimension. Notice that the statistics appear in the table in the same order that you specify them in the dimension expression, min, before max. In both of these examples, statistics appear in the column dimension. You can specify statistics in any dimension, but all statistics must appear in the same dimension. In this third example, the statistic percent of total frequency is specified in the row dimension. Also, notice that the statistic now appears before the variable. In the table that this statement creates, look at the row dimension. Notice that the statistic PCTN appears first, followed by country. You can specify different statistics depending on whether your dimension expression contains any analysis variables. If the dimension expression contains only class variables, you can request only the statistics N, the number of non-missing observations, and PCTN, the percent of total frequency. However, if the dimension expression contains at least one analysis variable, you can request any available statistic. To see a list of all the statistic keywords available in ProcTabulate, click Details. Take a moment to answer a question. All of the ProcTabulate tables shown so far in this lesson display statistics for each combination of unique values of the class variables. When you work with ProcTabulate, each combination of unique values of the class variables is called a category. But what if you also want to see statistics that are summarized across all categories? For example, this table shows the minimum and maximum salaries for Orion Star sales employees for each combination of unique values of country and gender. Suppose you want to display statistics for all employees in each country. To summarize all categories, you can add the special class variable all to dimension expressions in your table statement. To show statistics for all employees in each country, you need to add a summary row. To add a summary row, you specify all in the row expression of your table statement. In this example, all now appears in the row expression in the table statement, following the variable name. The ProcTabulate step creates the following table, which displays a row for females, a row for males, and a row for all employees in the dataset. As with other class variables, the default statistic for all is N. However, this table does not show the default statistic. Here's a question. How do you create a summary column?